Bismillah Rahman Rahim. Assalamu alaikum students. I hope you are fine and you are doing well. Welcome to another update from my past two lectures, which were online as well. I saw your attendances through the WhatsApp, and I was very happy to see almost everybody was there watching the live stream. And sometimes I have uploaded these two videos already in my channel, in the YouTube channel, and basically, you know that the upcoming exams and tests, they are coming from this sort of literature. So if you feel like that you still did not understand something or something was missed, please go back and watch those videos. Now, there are many questions you are asking about test number 3. I think you remember I told you this many times in the classroom that tests and quizzes, they are actually all according to a plan discussed with you. So before we get into the discussions and also your questions, I would say that please just relax. You have seen that the tests, when we take the tests, if you have studied well and if you have understood the lectures well, tests are basically multiple choice questions. So it will not be a big issue for you. And it's just 40 minutes. And our class timings, we know the class timings, we already know it. It is about 2 hours and 40 minutes. So it will not be an issue for anybody of you. And please keep in mind that, yes, it is a problem for you guys, but also a problem for us. And we want to get at least some exams or some data or some, how to say, uh, tests or quizzes or some sort of exams which we can take so that we can make some sort of grades for you. Otherwise, if we postpone or if we miss, or it will create a lot of issues. And you know, one thing you know, that if you do not take any test or quiz in a normal situation, it costs you less. But now it will cost you very much, because left, maybe 70% is left, or maybe 65% is left, and that 65% will be actually translated into the grade. And that 65% probably, okay. So please don't worry, we will discuss this in the end, at the end of the lecture. So just for the sake of my recording, I will say the intro again, and then I will start my presentation. After the presentation, we will discuss about tests and other questions if you have. Bismillah Rahmanir Rahim. Assalamu alaikum. Dear students, welcome to another online lecture of Introduction to Engineering Design. I hope that you have liked my previous lectures. Issues with the lectures or some glitches, they can watch the recorded versions. I have uploaded the recorded versions as well, and I hope that you go there and watch it again. And if again you have questions, you can ask me, because all the upcoming exams, your tests and quizzes, they will involve this knowledge, which these lectures will be basically being counted there. And also the knowledge you get here will be required for your final report and whatever literature, whatever you have to give us. So please take it seriously, as you are taking already, and make sure, but it was part 1, that is chapter number 12, which is of our book, discussing about mathematical modeling in design. Now, as I described before, that mathematical modeling is very important. It is very much involved in any engineering design, and especially in your course. So hopefully this information will help you. So again, the same question as I asked from you guys, that in this illustration, which is basically a 5-stage prescriptive model of the design process. This is basically complete design process, involves all these steps. The rectangles are the design process, while the ovals are the inputs or the output stages, as I always describe to you. And this is a very important design process model. This is a 5-stage model. Now, again, I will ask where we are here. So we know where we are. I give you a few seconds to think about that. So here we are, preliminary design, where we do the modeling, the analysis, and then we choose a design, and then we test, we evaluate, and see what we are getting. If our evaluation and our models, they are working well, then we go ahead. Otherwise, we go through the same iteration as we discussed in our last lecture. So after today's lecture, what will you understand? The students, you are definitely your students, and what will you understand out of this? So the first thing, we will be aware of mathematical principles in design. So what mathematical principles, rules we use in a design process? The second thing is different connections in springs and resistances. And you know, basically, I told you in the last lecture also, so this is either can be series or parallel or combination of both. It can be series or parallel or combination of both. Also, the law of conservation and balance equations, basically, which are used in modeling and simulation. And different model types. And this is very important. How we have to understand what is actually simulation. And there are many different programs which are available in different fields, which we can use to simulate our model. So it will come upcoming. You can just stay tuned. So yesterday I explained you this dimensional homogeneity. Homogeneous means same. So in mathematical modeling, every equation we use must be dimensionally homogeneous or dimensionally consistent. This I explained in the last lecture as well. And it is quite logical that every term in an energy equation has total dimension of energy. So suppose you have a term or equation where everything is energy, so all the equations should have dimension of energy. Or if we are having a term like a mass, okay, in the balance of mass should have the dimension of mass, that is kilogram. So which we know what is an abstract. So from abstract, the word abstraction. But in abstract, we have to use the right level of details. If we do not have good details about our modeling equation or how to construct equation, we can get into some sort of trouble. But it cannot be too detailed also, because then it will become too complex. So it should be like an khulasa, like an abstract. And scaling means you can either increase it or decrease it. You can change the shapes, like weighing like a weight, like wazn. So weighing the elements used in the modeling equation. Abstraction depends on scaling each element in the orthogonal equation. So let's take this example. You know, this is F is equal to Kx is an elastic. This is the equation for the spring, where F is the force we apply to the spring, K is the spring constant, and X is the displacement. The more you pull the spring, the more power it will have. So this spring basically this model can be used to model behavior of a ladder. You know, Sulim, the ladder. If you make a ladder, very high ladder, what type of loading, if the wind comes or some force come or earthquake come, even a tall building if you make, that building can be simplified with a small spring. And in the previous lecture we saw some of the examples like this. Now there are few things here, which is one is called linear and what is called non-linear. So the models of devices or systems are said to be linear when their basic equations, either algebraic, differential, or integral, are such that the magnitude of their behavior produced is directly proportional to the excitation or input. So what is the output should be directly proportional to the input. So have a look at this example here. The volume of a cylinder V can be given by pi h and r square, where h is the height and r is the radius. And you can see from here, V is basically directly proportional to h. This is like a straight line. But it is not directly proportional to r, because r is now squared. So if you plot V and r square, it will not be straight line. It will not be linear. It will be non-linear. So V is linearly related with h and non-linearly related with r. Now, conservation. Remember that all the energy, any energy cannot be created, not be destroyed. So it means that if we have one energy, that energy can be transformed into another energy, but it will still remain conserved. It will stay there. It will be there. For example, there is an example I give you now. You know what is a pendulum? This is a pendulum. If you look at the pendulum, suppose we displace this pendulum from here up till here, this point. So we are displacing it. Now we know there are two energies, kinetic energy and potential energy. The kinetic energy is basically because of the motion, and the potential energy because of the height. So when we start moving, it has the kinetic energy. So the faster it moves, more the kinetic energy. When it goes here, now it's a potential energy. So if you leave it from here, because of the potential energy, it will come back to that point from where it started. So if you look at this whole system, the energy is still there. Energy never dies. So either it is potential energy. If you leave this, it goes down, it converts into kinetic energy. And if it is kinetic energy, you displace it upward like this way, it becomes a potential energy. So that means that energy cannot be destroyed or can't be, it will always be transferred and it will remain conserved. The energy will still remain there. So you can see these 2 points. At one point, when you have given it height, it's maximum potential energy, and at low point is maximum kinetic energy. So energy is basically changing, oscillating, but the total system remains conserved. So for example, if there is a physical property or attribute or a property which is related to time, say nt, okay, so the law, balance law, will be given by this, that the rate of change of this physical attribute, any attribute of the system, will depend of n input minus n output plus gt minus ct. So n in is the flow or influx which is coming into the system, like it is an input. N out means the output, whatever getting out of your system. You remember that black box that we give an input, then there is an output out of there, and from the output we know what is the input. We discussed it in the class. And what is G is the rate at which N is generated within the boundary. So either it can be heat or whatever being generated because of this input, there is something happening inside. That is called GT, and CT is the rate at which N is consumed within the boundary. So generation and consumption, you know, if there is something which is consumed, for example, if you are consuming some sort of power, maybe there is heat generated out of, like a fan, you know, a power system or somewhere, a power supply. If input comes inside electricity, you know, even your laptop, you can see inputs, there are power inputs, and then because of the system inside, heat is generated. So this is basically a very important equation. So there can be a situation where there is no generation or no consumption within the system boundary. Can be an ideal system where that means that in that equation, if G becomes 0, C becomes 0, so it means that now the law becomes conservative. And as I said, so you can see that GC and that G and C values are gone away now. And now we are either left with input or output. That means that inside the body, there is no loss at all. It means that it's a very, this system is basically an ideal system, a good system, ideal system. But most of the time in design process, when we see or different components we see, there is always some sort of loss and consumption inside. Nothing is 100% perfect, but in some cases it can be. So for example, the equation which we did now for in the back, that example, the pendulum one, you can say nothing is, there is no G, there is no C. It's only at the input, either it's kinetic energy or it is potential energy. So it is only conserving, but there is no loss. So there is a balance there. So let's give some examples. So I know you are from different faculties, I mean different engineering fields. Some of you are from, if Ahmed is there, probably I know Ahmed. He is from chemical, and then I know many of you who are from electrical, mechanical, civil. So let's give some example to you. For example, here, let's say our device is a reactor. We are doing some chemical reactions. We are putting many things, many different mahluls or, you know, solutions, and trying to get out something out of this. So what is the principle we are using here? The principle is conservation of mass, the total mass of those chemicals. What is the total mass? Can we conserve it? So if you look at the output, so you can basically model it like a container in which we put some mass, some chemicals, and then we see what is the output. So if there is a change in the mass, if there is a change, that is delta mass is basically input plus output. And you know there will be some gases, and gases will go away out of here. So the input and output may not be the same. There will be some loss, that equation which is here, G and C. But still you can see the mass, the overall mass of the system is like water. We boil it, it goes into steam, then you condense it, it becomes water. So the mass is still conserved. So in this example, this is the same thing. Let's give some examples from other fields. Civil engineering, from civil. I hope some of you are from civil as well. So let's say this is a device, and you are creating some sort of civil structure. On each structure there are some loads. This one is called conservation of momentum mean motion, right? And at different points there is force in some direction. So let's see how it is. So it is like, you can see there is a force which is vertical but on the upside direction, and it is also pushing downward toward the earth. And also when it is something is moving in horizontal direction, so if there is one force in the horizontal direction and other force in the negative horizontal direction, so opposite direction. So if you take the overall summation of the horizontal forces, the net result will be 0. And if you take the summation of vertical forces, the net result will be 0 here. Then you can see the moment is conserved. Doesn't matter how many moments and balance and forces are involved there, but the net result becomes 0. And there is another example coming up, and you will understand from there as well. I know that at the moment none of you probably is at a level where you have taken your civil engineering courses where you can understand these things in a detail, but just for a basic understanding, we are giving you this sort of examples so that you can have some sort of understanding. There is another example here. From mechanical engineering. Look at this car. So this car is standing somewhere in the parking or somewhere. This car is also having conservation of momentum. Now, if you look at this car where it is standing, when it is standing here at this point, there is a force which is pushing downward toward the earth, and the earth is also pushing it up, and the net result becomes 0. That's why the car is here. If the car weight become more, it will make a hole inside the earth and it will start going down. And if the force coming from the ground, from the earth, is higher, the car will start flying. But we can see here the net result is 0, so the car stays on. Also, if you look the mass of the car, and then multiply it to the rate of change of x, it will be basically downward force minus upward force, and net result will become 0. This is the reason why the car stays. And not only the car, any mechanical or any machine or human or anybody who is standing on the ground has the same thing. If one force become bigger than other, either the guy will fly up, person or the object, or it will sink into the ground, but it is not happening. So there is some sort of balance there. Okay, electrical engineering. You know, these are basically 2 loops here with 1, 2, 3, 4, 5, 6 resistances with 1 power source. So here we can see conservation of charge. The power in the battery has a charge, and the charge is conserved. How? If you look at any node here, the current entering and the current leaving, if the current is coming, say, from this side, and in this node, in this point, some current is going here, some current is going there. If you add these 2 currents and minus with this, the net result becomes 0. So for example, if current from here is coming 1 ampere, then when it comes here, 0.3 amperes goes here and 0.7 ampere goes here. If you add 0.7 plus 0.3, it will become 1, which is actually the same current which is coming here. And if at the node, the net result is the 0. You can see for each node, the sum of current I equal to 0. It's the same story at this node also, here also. This is a node and this is also a node. So here the charge is conserved. The net result becomes zero. So it's a balanced system. And in the same circuit, there is a conservation of energy. If we go into the energy, that's the voltage, I square R, power and energy. If you look at this loop, the IR is, V voltage is basically Ohm's law, V is equal to IR. So this will be I1 R1, I2 R2, I3 R3. Now, if you take the voltage here, suppose here is 100 volt. This will be say 30 volts. This should be 50 volt. Okay, and this should be 20 volt. 50, 20, 30 become 100. The net voltage drop which become here, and if you minus with this one, will become zero as well. So not only for the current, also for the voltage, the formula, the conservation, the principle of conservation applies. Now, yes, this also simulation. The simulations are basically very much important in every field, every research and development field. Simulation is very important. So, for example, imagine that in my field, when I was doing engineering, my PhD, and I was doing the engineering design, I have to create an antenna, a small antenna. I cannot create an antenna, just go and fabricate. First, I have to make some model, a small design. The design will be based on electromagnetic principles. There are formulas. I will use the formulas. Then I know the dimension, the feed, and everything. Once I have the sketch and all things on the paper, then I will open a software. In my case, it was CST, Microwave Studio software. This is simulation software. I will open it up. Then what I will do, I will design my antenna there. I will put the in feed and everything, and then I will run the simulation. The computer, the method of movement or whatever program in the back end, they will calculate all the electromagnetic fields, and if I want to see what is the gain, what is the directivity, what is the power of this antenna, what is the frequency band, and how it's doing, everything will be in the software. The software will tell me everything. Once I am done with and I know that it is done, then I will go for the fabrication. And why we do this, basically people can ask why. I mean, if you can say that I'm a big engineer or big researcher and I know the formula, then formulas has to work fine and everything will be fine. This happened to me once, that I was designing some sort of electromagnetic structure, and there was a problem in the simulation software. I did not select some proper values, or values were proper, but maybe some setting there was some issues. So what happened that when we went through the fabrication far apart, and I spent about probably $3,000 just for the fabrication and other things which I were involved in that design. This is during my PhD. Right answer. So then I came back to the other software called CST Micro Studio. I changed the parameters and some settings, and then when I simulate, I got the right answer. But it gave me one experience that we have to be 100% sure in the simulations. Everything is simulated. So mechanical engineering has mechanical software, electrical has for electrical, electromagnetics, electromagnetics. And nowadays, every research which is done cannot be done without simulation. Even a circuit, a small circuit, they simulate, they check the answer before they fabricate. So in your case also, because now you are not making a prototype, but if you have some sort of model, electrical model or mechanical model, whatever, and you have some sort of simulation data and you get some simulation results, that will be really good for your final report. Even it will show you whatever you are wanting to do, can it be done? And when you fabricate it or you make the prototype, will the prototype will work exactly the same thing, same way? So let's go into this cycle. There is a cycle here. If you can see that cycle. So First of all, we will have a model. Here you can see there is a model. We have an insight. We know what we want to make. We do it in our, we can use an algorithm, we can use model paradigm, we can use technical knowledge, whatever it is. So that model, then it goes into simulation. You will use a software engineering, project management, some sort of, development technologies we will use. From there, you go to the computation technologies. In computation, we use, definitely when we do simulation in a software, you should think that the software has something on the back end also. There are some codes. There are, in our case, like electromagnetism, there are method of moment, finite integration method, finite differential method. These software actually use this thing in the backdrop, in the back end. Front end looks very simple to us, but back end has a lot of codes. So simulation actually use this to calculate and compute the answer for you. And then once you run the simulation and then you got the results, after those results, you go and check, analyze, and maybe you go and fabricate it and measure, and then see that your measurement results are equal to what you got in the simulation process. If you did not get the same results, that means either your analysis is not correct, either your model is not correct, or maybe there is something with the simulation software. There are some settings not proper there. So I'm not sure now at what stage your projects are right now, but I really recommend all of you guys to please use at least one software in which you can present your data, which will give us a little bit of confidence about you have actually learned this process and you have applied into your project. Process of for design, then we put into the simulation that design, and then simulate and get the results. If the results are good, we fabricate, and if the fabrication gives us exactly the same results we modeled and simulated, then it means that we have got a perfect project. So there are many programs which we can do basically simulations. So Arduino, most of you know it already. And basically it's a microcontroller, and there is a microcontroller. You can program this Arduino, and you can create many different projects based on Arduino. You all know this. So this is one of the example, basically related to the software engineering or computer engineering, you can say. SolidWorks, you guys already know. SolidWorks basically not exactly a simulation software because it doesn't give you some data, but it's like a modeling software. You want to model something, you create a part, you want to create a dimension. For example, you are creating an electronic power supply, but power supply has to be in a box. So how to create the box, what will be the dimension, what will be the dimension of your printed circuit board. And I know everybody of you in this SolidWorks, you have studied this in your previous classes and previous courses, I would say. MATLAB, nothing new to you. And MATLAB use a lot of algorithms, and there are many, environments there, and you name it, civil engineering, mechanical. There are so many Simulink. If you go into Simulink, and there are so many models there. This is also a very good one. And here you can basically simulate a circuit or a system in MATLAB. Then you get the end result. Then you see that the end result which you exactly want to be, as I said, has many, a company from US. It has many softwares which for structural, the structural mean from civil, finite, which includes finite element method, computational fluid dynamics in the fluid one. This is from mechanicals, and heat transfer. This is also for mechanical and thermal engineering. And ANSYS also have ANSYS HFSS, high frequency structure simulator, which I showed you, from electromagnetics also, which solves our electromagnetic problems. This is Abacus, FEA. So this is also a good software for automatic cars. So if you have to model a car or design a car or see the different aspects and engineering aspects of a car or automotives, any automotives, you can have to use this software, even for aerospace, like aeroplanes and something. So you can see it has a lot of capabilities, this company. All these names you can Google, you can go online and check, and hopefully if you are interested, you will find, even if you look at a screenshot, some sort of screenshot of this softwares, you will realize that how powerful they are. Life has become easier. In the past, old times when there were no software, people have to write their own code. So every engineer or every researcher has to write his own code to solve a problem. But now we have got ready-made things. We only have to know how to model and how to simulate, and it is very easy. There is another one called COMSOL Multiphysics. This one probably available in our university. This one is for physics and engineering applications. For physics, heat transfer, heat flow, many things. This is also a very big software which can be used for modeling and designing different projects related to physics and engineering. That's why the name is Multiphysics. Then we have Pipe Flow Professional. This is also software. You know the pipes which we have in every building design. We have to have some sort of pipe where we run through the cables. So the pipe should be bigger, smaller, what should be the strength. So this simulation software basically is used. I think this will be also related to civil engineering. And there is a ChemCAD. This is for chemical engineering. So it is for petrol, pharmaceutical, medicine, mechanical, environmental. So many things it can have inside. And these softwares, if you go and buy them, they are really very expensive softwares. But they are available, and thankfully, and we can use them, and for almost every field. So all of you, whichever field you are, you will definitely find a simulation software for your types of project. The project types which is related to your field, you can have at least one software there. Then 3D electromagnetic simulation software. This can have microwave circuits, antennas, resonators, filters, waveguides. Probably these all words probably new for you, but just to give you just an idea that this software is basically used for antenna design and many things related to the frequency and communication. Okay, this one, most of you, I would suggest, please check for this Proteus and PSpice. I am quite sure PSpice is available in our university. Proteus probably yes. And there is another one, LT Spice. LT Spice. If you go and check, you can download, and whatever circuits you have, you can just make it inside the software, and the software will simulate it for you and also give you the results, whatever you want to make. For example, if you want to make a timer, or you want to make a voltage amplifier or power amplifier, whatever the circuit you design or make on a paper, after that you just put these components inside the software, and then you just run, put the monitors, and the monitors will then tell you what is the outcome of your project or your design. And if the outcome is correct, you know that yes, this is what I want, then you can buy the parts, and then you can connect the circuit, and the circuit will exactly work the way you want it to be worked. This one I already told you, CST Micro Studio for antennas and electromagnetic structures. And this one I used it for many years, and I'm still using it for my current research which I'm doing. So my WhatsApp and YouTube is live here also, that if you want to ask a question, I will take the question. But before that, I think the first and the foremost, what is the important thing is that your test number 3 tomorrow. So for ZA7, the morning section, you start at 10 and you go until 11:50, that's about 12. So your test will be available to you, it will be finished. But remember, the test will automatically be submitted after 40 minutes. And if you make a mistake sometime, and I hope you will not have any other class at that particular time. And the other thing is that When you are doing it online, make sure that your internet connection is working well, and also the computer which on you is a power. I know in the classroom sometimes the battery issue, you have to run power source, and but at because at in the classroom face-to-face environment, if there is an issue, instructors can help you. But in this scenario, things can get little bit difficult. So please, I suggest you for ZA7 tomorrow 11 a.m. For section ZA, which is 1 p.m. to 3 p.m. For you, it will be available at 1 p.m. Start and input and read the whatever the instructions are, but it is 40 minutes. So if you delay, the test will close. And as you know that the test and quizzes and all these are in the calendar, and the calendar is fixed for all the sections, for all the instructors. So for me to change it just for you is not possible. So I hope you will do very well in that. If you have any other questions,